So take very seriously these predictions. This is part 1. We will have part 2 and part 3 for the final part of prediction chemistry paper 3. So I want you to concentrate and take it serious. Make sure you know how to go through from number 1 to the last, step by step. Welcome, and remember to share to others. Welcome wherever you are. This is Teacher David. I want to take you through chemistry paper 3, the year 1998, as we prepare for this year's exam. You are provided with M, hydrochloric acid, solution N containing 8.8 grams per liter of sodium hydroxide. So 8.8 grams per liter, I want to explain this. This means it is 8.8 grams in a liter, or 8.8 grams in dm cube, because 1 dm cube is equal to 1 liter. Those are the key words you need to know. 0.5 grams of an impure carbonate, solid P. You are required to determine the concentration of solution M in moles per liter, percentage purity of the carbonate, solid P. Remember, moles per liter is equal to morality. What is morality? Is the number of moles in a liter. So morality is the number of moles in a liter. So moles per liter is morality. Let's go to procedure 1. And remember, a practical paper, the most important thing is the procedure. So you need to is the procedure. Most important thing is the procedure. Fill the purity with sodium hydroxide solution N. So we know solution N is sodium hydroxide. Fill the purity with sodium hydroxide solution N. Pipette 25 centimeters cube of hydrochloric acid solution into a conical flask. So what we have, so it is HCl that is going to react with sodium hydroxide. You should know the reaction. Sodium hydroxide plus HCl, what does it give you? What is the mole ratio? That is very important. So I have filled the table. Make sure you fill the table with 1 decimal place, and make sure the table is completely filled. Always initial use 0.0. This is no harm, even if you use the remaining, but I encourage you to use 0.0, 0.0. Then put this number here, put this number here, and put this number here, and your table is complete. What is the average volume solution N used? Average volume, that is 24.1 plus 23.9 plus 24.0. You divide by 3. The answer is going to be 24.00 centimeters cube. I have put 00 because we usually say that the average volume should be given in 2 decimal places. Determine the concentration of solution N in moles per liter. I have told you that the concentration in moles per liter is called morality. So this formula is very important. We have 2 important triangles in calculation or in the mole. So let me remind you this one. So this one, you write here morality. Up here is mass, which must be in grams per liter. And then here is RFM. Now, if you are asked N of them, you see what you have been given. Now, solution N, we were given the mass in moles per liter. So look at here, we have N, we have 8.8 moles per liter. So we have mass in grams per liter. We are looking for morality. We have RFM from here. We have been given this RAM of sodium hydroxide. Therefore, we will get the, therefore we know now that morality, this morality, you hold your finger like this, is equal to this over this, is equal to mass in grams per liter over RFM. So now let's get the RFM of sodium hydroxide. RFM of sodium hydroxide NaOH will be equal to 23 plus 16 plus 1, and that one is 40. Now we will have 8.8 over 40, and this one will give us 0.22. Capital M stands for molality. Also, you can write one as ml per liter or per dm cube, whichever. That one is the number of moles in a liter. Concentration of solution M in moles per liter. Remember, M is reacting with N, and M is HCl. N is sodium hydroxide. So the reaction which is taking place, that's why I told you, you should be able to know what kind of reaction you expect, and you should be able to write an equation and balance that equation. For this one, it will form sodium chloride plus water, and the mole ratio is going to be 1, 1, 1 everywhere. It means that the number of moles of sodium hydroxide is equal to the number of moles of HCl. Yeah, because the ratio is 1, 1. It is already balanced. Now we know the number of moles of N. We don't know that. We know the number of moles of N in 1,000. But we used N 24 centimeters cube. We can get the number of moles of N we used, then we will know automatically the number of moles of M. So moles of N used, 1,000 centimeters cube of solution N is equal to this, because this is a molality. Molality is the number of moles in 1,000. M stands for number of moles in a liter. A liter is equal to 1,000 centimeters cube. So this one contains 0.22 moles. Now M, once you write it this way, this one becomes moles and not M. Then now we will find out 24 centimeters cube of solution N will contain how many moles. Therefore, we will say 24 times 0.22 divided by 1,000, and this one will give us 0.0528 moles. Now, this is the number of moles of N used. Number of moles of N used, that is sodium hydroxide. But the ratio here is 1 to 1. It means the number of moles of sodium hydroxide is the same as the number of moles of HCl. Therefore, moles of M used is 0.00528, because the mole ratio is the same. But we are being asked concentration of solution M. Concentration in moles per liter means molality. So we would say, how much of the volume of solution M used? You go back to the procedure and find out. We were told that pipette 25 of hydrochloric acid solution M. So we used 25. 25 of M reacted with 24 of N, the reaction to reach the end point. So you say now here that 25 centimeters cube is equal to 0.00528 moles. What about 1,000 centimeters cube, which is a liter, will contain how many moles? Now it is 1,000 times 0.00528. You divide by 25. And this one will give us 0.2112. Capital M stands for the molality. So this is the molality. This is the molality of solution M. That is the concentration in moles per liter. It is called molality. Using a measuring cylinder, measure out 100 centimeters cube of solution M into a 250 centimeters cube beaker. Add all of solid P into the beaker containing solution M. Swirl the mixture and allow the reaction to proceed for about 4 minutes. To swirl is to do like this. So label the solution obtained here as Q. So when after the reaction, the solution that is remained or obtained there is called Q. Fill the puree with sodium hydroxide solution Q. Pipette 25 centimeters cube of solution Q. Pipette 25 centimeters cube of solution Q into a conical flask. Add 2 to 3 drops of screen methyl orange indicator and titrate. So after following that instruction, we will have our table here. I have filled the table like I explained earlier. So let me get the average volume. Average volume, it is 12.3 plus 12.4 plus 12.5. The answer here is 12.40 centimeters cube. Calculate the moles of hydrochloric acid in 25 centimeters cube of solution Q. So remember, solution Q is the solution that remained after reacting with solid P from M to Q, right? So we don't know anything about Q, but we know Q reacted with N. Now we know N, we know the molarity of N, everything about N we know. So we start with calculating N because we know again the Q is HCl, but diluted after reacting with solid P. And M is sodium hydroxide. Sorry, I'm saying we know solution HCl in 25 of solution Q. This is HCl but diluted. So we know the sodium hydroxide solution that the reacted because it has not changed. We know the molarity, but again, we know the volume of sodium hydroxide used. It is 12.4. So we know that 0.22 moles. Where did I get this one? We had already obtained the molarity of N here. This was the molarity of N. So this is the number of moles of N in 1,000 centimeters cube. We will now ask, what about moles of N in 12.4 centimeters cube will contain how much moles? So which is 12.4 times 0.22 over 1,000, right? And this one is going to give us 0. So this is the number of moles of solution N that reacted with Q. But the question is asking us to calculate the number of moles of Q. What is the relation between Q and N? This is sodium hydroxide and this is HCl. They will react using the same equation as we saw it here. The equation remains the same because it does not change. This is the equation, meaning the mole ratio is 1 to 1. Since the mole ratio is 1 to 1, it means moles of sodium hydroxide solution N that reacted with Q will be equal to the number of moles of Q in 25. Therefore, moles of Q is equal to 0.002728. Why? The mole ratio is 1 to 1. Calculate the number of moles of hydrochloric acid 100 centimeters cube of solution Q. We know now moles in 25 of Q. What about 100? 25 centimeters cube of Q contains 0.002728 moles. 100 centimeters cube of Q will contain how much? 100 times 0.002728 we divide by 25, and this one will give us 0.010912 moles. So this is the number of moles in 100 solution Q. Calculate the number of moles of 100 the original hydrochloric solution M. Remember the molarity of M, we calculated it in the first procedure, and we got it like this. Let's go back and refer of M, which is this 0.2112. So now we are going to use this one because we know this is the number of moles in 1000. We will ask what about the number of moles in 100. So 1000 centimeters cube of M contains 0.212 moles. 2.1, as we have seen on previous, we will ask 100 centimeters cube of M original will contain how much? This 100 times 0.2112 divided by 1000, and this is 0.02112 moles. This is the number of moles in 100 of the original. Calculate the number of moles of hydrocarbons that were used up in the reaction with solid D. Now, this is to get the moles in 100 centimeters cube solution M minus moles of 100 centimeters cube solution Q. And we have all of that from here. Moles in 100 solution Q, and this is our moles in 100 original solution M. So to get the moles that reacted with P, it is this minus this. And the answer is 0.01028 moles. This is the number of moles that reacted with the carbonate of HCl. This is the moles of HCl that reacted with the carbonate P. Number of moles of the carbonate that reacted with the hydrochloric. Now we know the number of moles of HCl that reacted with the carbonate solution P, solid P. Now what will be the number of moles of P? Here what you need to understand is the mole ratio of HCl when it is reacting with the carbonate. Remember, carbonate has a valence of 2, and this one has a valence of 1 hydrogen here. Therefore, the ratio is 1 to 2. 2 to 1. The ratio is 2 to 1. Therefore, now that we know the number of moles of HCl, the number of the carbonate, number of moles of the carbonate, now that we know the number of moles of the HCl that reacted with P, the carbonate, the number of moles of the carbonate is going to be a half this of this, because we say 2 is equal to this. 1 will be what? 2 is equal to this, what about 1? So it is 1 times 6 divided by 2, that is a half. And the moles of the carbonate is 0.005104. That is the moles of the carbonate. Given that the relative formula mass of the carbonate is this, calculate the mass of the carbonate that reacted. Mass of the carbonate. Now from the first formula, when you are doing moles, you know that moles is equal to mass over RFM. So mass is, if I want mass, it is moles times RFM. If I want moles, it's mass over RFM. So what I want is mass. Therefore, mass is equal to moles times RFM. Our moles is 0.005104 times RFM. You have been given 72, and that gives you 0.36 grams. So this is the mass of the carbonate that reacted. But remember, the total mass of the solid P was 0.5. So the percentage purity, it is the mass of this is the one that reacted, meaning it was the pure one that reacted with this. The impure one is the remaining 0 point something. But now we want the percentage purity. Percentage purity is this mass over the original. 0.367488 over the original 0.5 times 100. That gives you 73.50%. And that is the percentage purity. So look at this question very well as you prepare for your exam.